All right, what's up, everybody? Glad to see people are starting to join the live DATAcated Takeover session. You may be wondering, hey, where's Kate? Well, Kate's not here. I'm taking over DATAcated, a part of IBM Databand. So my name is Ryan Yackel. Glad to meet everybody here today. We're going to be doing some fun things. We have some swag giveaway that we're going to be doing. We've got some actual use case and live demos that we're going to be doing. We've got kind of an overview of what data observability is. I'll be talking about that today. So a lot of fun stuff that we have going on. So I'm really excited to be a part of this session today and kind of walk you through our perspective on this ever-changing data landscape and kind of where data observability falls into the picture. So hopefully everyone here is ready to go. If Kate can give me a thumbs up, I know she's probably in the live stream, just checking out to see if everything looks good. But everything looks good, then we'll go ahead and get going here. So again, my name is Ryan, and really happy to be here today. What I want to do is kind of give you a lay of the land of how we're going to go about this session. So the first thing we're going to be doing is we're going to talk about like why data observability matters and what are some changes, what things have to change have really changed over the years around why there's a need for data observability. Then we'll be talking about some what's needed to actually have this continuous data observability standpoint as you're going into modern data infrastructure, modern data stacks, things like that. Maybe dealing with a lot of issues that maybe can indicate that you actually need a data observability solution, but you can't really put together exactly what those things are. So we'll kind of lay out some of the things we hear in this space. And I'm actually going to get into some live use case demos. So traditionally, when we talk about data observability, what we're going to be doing is talking about, hey, what are some things that a data engineer really cares about? What are some things that a analytics engineer really cares about? What are some things that maybe even a data analyst would care about as they're going about their day around data quality and data reliability issues that occur. So I'll be going through some of those things first. So okay, but first, really quick background on myself. So I'm Ryan. I'm CMO of IBM Databand. We were acquired by IBM back in July, part of their kind of big push around modernizing the modern data architecture for enterprise clients and also small and medium-sized companies are kind of dipping their toes into this thing called the modern data stack. So I've had a lot of experience in startups for the past few years. Working at IBM has been great. We've been able to really bring this observability message to a lot of our clients who are dealing with reliability issues and also data quality issues. I'm also a comic hero nerd, so I'm really, if you want to talk to me about Batman or Superman or Wonder Woman or whatever, I'm happy to talk to you about that. That's probably one of my biggest passions outside of coffee. And then I got 3 kids, obviously 1 wife, 1 dog, and all of them are girls. So I'm pretty much outnumbered as it relates to the Yackel household. And then from a observability standpoint, I speak a lot on data observability things. So whether it's communicating things like, hey, here's how our product works, like I'm doing today. Here's how Databand can actually be a value add to your data teams today. Whether it's kind of talking about what is the observability and a nice logical standpoint, or even creating things with people you may know of, like Rabbit from the Rabbit Show, and talking about how we can scale these things into modern data stacks, and also talking about what's the real reality around data observability in the workplace. And recently, we just did a really fun coffee event with Kate from DATAcated as well. So if you ever want to learn how to actually make a really good cup of coffee, and you want to learn how those things connect into measuring your data quality and data reliability, part of data observability, I'd definitely love you to check that session out as well. It's a lot of fun. Okay, so let's get into the session today. We're only going to go for about 45 minutes. If you have questions, go ahead and put those into the comments. I'll try to actually answer those. I have this, if you see my eyes kind of darting back and forth, I've got 2 screens set up here. I'm trying to look at the comments, trying to look at the demo I'm about to give, look at the slides. So all these things are kind of in play. So if you see my eyes kind of going away from the camera, it's not because I'm not trying to give you my attention. It's because I'm trying to manage all the awesome tech that we have going on. But let's go ahead and get into the actual content for today. So this is a interesting diagram that came out recently. This is from the 2022 State of Software Spending by Battery Ventures. And one of the things they said was, if you look at the top priorities for hiring as it relates to CXO priorities, you look at a data engineer was one of the top things that it was the top hiring position that they were looking at for hiring in 2022, and then actually beat out security engineering and DevOps engineering, which is pretty crazy. And if you look down below, you see data scientists, you see front end, back end developer. All these are important, jobs and positions to fill as you're scaling your company. But this really shined a light on the fact that there's a lot of problems as it deals with core infrastructure and data engineering that requires CXOs to prioritize that. And the reason why they're hiring and needing these particular skill sets is because of this, right? This is a plethora, one of many diagrams out there around either machine learning or data landscape or all the vendors that are out there, from infrastructure to analytics to machine learning to observability. And there's so many tools out there. It's really exploded. It's way too much when it comes to actually people trying to understand what are their problems and how can they actually solve those problems in a data-driven company today. And so there's a reason why data engineering teams are a lot of teams are in charge of a lot of these things. They're in charge of moving the data from one endpoint to the other, from the producing layer, delivery layer, all the way to the consumption layer. And when we talk to customers, a lot of times they feel like this. They feel like they're insanely overloaded, way underwater, and they don't really know how to get out of it. They're constantly being charged with complex pipelines, lots of data sets, lots of volume, and all these things could break because in a traditional data ops assembly line, it's pretty complex from your source all the way to access. It touches different people. It can touch all the way from an architect all the way down to the business users that's consuming it. And it goes through all different types of transformations or loading or changes in schemas. All these things kind of play together, and it's very, very, very complex. And when you layer in the fact that you also have to add in this orchestration, development, testing, deploying in this entire cycle with all these different people that could be touching the data, things actually break, and they break frequently, right? This happens kind of out of nowhere. We hear this a lot. We hear that, hey, this thing that we have put together that's really, really awesome and modern, and we have best of breed tooling and all these things. Well, it can break and it comes out of nowhere. And a lot of times data engineers don't even know that it's hit them. So it could happen whether you're ingesting or orchestrating data with Airflow all the way to doing some model transformation and testing with DBT, and then possibly having it land in a Snowflake table. Those are some examples we'll be talking about today in the actual demo that we go through. But in the real world, this breaks frequently, and we hear this from our customers. So this is from a cryptocurrency a platform provider. They said, we cannot afford to wait so if a critical pipeline is down, because then we'd be way in breach of our data SLAs. It's a problem with teams delivering data on time and also making sure that their infrastructure, the data pipelines are set up in a correct way so they can meet those SLAs. This is from a 3D design software company. It said that when we present our customers with inaccurate information, the results are lack of trust, right? That's a problem for them. They have the end users or end customers not actually trusting the data that's actually being delivered to them. And a real estate software company said that, today we need our customers to tell us if our data deliveries are late, and it's very, very frustrating. We don't know if there's slow queries or hung or data is not actually moving in the pipeline. You can have, again, this really awesome assembly line, but if you don't even know if things are broke or not even being fixed or not even being worked on, rather, then it becomes frustrating because you don't know what you don't know. And then one last example is from an investment advisor company saying that, every day our source data has missing, inaccurate, or incomplete values, and that results in poor data. So these are all real quotes. I didn't make these up. I'm in marketing, but I promise you I didn't make up these quotes. It'd be very easy for me to do that, but I did not. I promise you. Scout's honor. These are actual real things we heard in discovery calls, in qualification calls, to see if there possibly could be an issue around observability that observability could actually solve if you had that kind of in place. And the way I like to give an analogy to data observability is using an example of Formula One. So anyone here, I'm wondering if you've ever watched the Formula One Drive to Survive show on Netflix. It's one of the coolest shows, I think, reality shows, quote unquote reality shows out there today, because the whole goal of this Formula One racing team, right, is you want to build this amazing car, and you also have a driver that's going to be driving this car. So if you think about it, the person who's driving the car is really like your data team, right? And then the car itself is like this modern data stack. If you ever watch this show, they talk about all the time the car this year, the car next year, or a car didn't perform in the last race because there's so many things going on in that car. There's so many things that go into this car and driver relationship, similar to like a data team and the modern data stack that they actually have, right? Yeah, Susan just said it's down to tenths of a second. Exactly. That's something that they're always monitoring and needing to fix, right? So how do they fix these things? Well, how do they know if there's issues? Well, in a Formula One car, this is why there's a control center or control group that they always pan to in the show, that they're monitoring all the things going on in the car. Like, what was the lap speed? Is the tire pressure good? Is the engine performing the way it should be performing? Or the brakes bad? Like, all these things kind of factor into, is the car going to perform in the best way to get around the track as fast as we can, aka deliver the data as fast as we can, and then alert us if we need to slow down, speed up, come in for a cockpit change, things like that, so that they can know as fast as you're going, they can know to slow down if they need to. And I like to say that's basically what observability is doing. Data observability is doing in your modern data stack. What we're doing is we're connecting into all the different metadata that's around your modern data stack to let you know, hey, there's an issue here. Hey, there's a problem here. Hey, there was a schema change. Hey, that job that you said was supposed to complete at 2:00 today, it's still hung. It's still going, right? That's something you need to have. You need to be able to alert when things are going wrong, so you're not to slow the data team down, but also alert them around things they need to fix so they can get going and get up and running as fast as they can. Because again, getting back to the example I gave for at least from the data engineering side, is they're so overwhelmed with the amount of data they need to push, and what they don't need is more and more issues maintaining different pipelines and fixing pipelines. They much rather get them in the hands of the end consumer. So, before or without data observability, a lot of times it kind of looks like this, that diagram of that, complex data ops cycle from source all the way to access. If you don't have sensors like we talked about in the car, or we don't have something that's tying into your source data around the metadata around that and alerting you on things that go bad, this is typically what happens, is that at the very end of the data and all the way to the data access point, you're alerted at the very, very end. So you're very reactive to these data issues. I was in software testing before, a couple companies before this called Tricentis, and we talked a lot about this a lot, which is, an issue in production for software quality, very similar to the issue you have in data quality for a data engineering team or data platform team, or even an entire data team. The longer it takes to detect it, and the longer it takes, the further it's pushed out into production, the more costly it's going to be. So you have things like data quality is never discovered. They're reported by data consumers that you don't want to be told by that by them on this, and it could be take weeks to fix because you don't know exactly where the issue is. When you layer in this data observability component to it, what you're doing is you're actually getting into this continuous work stream of detecting and resolving incidents in near real time. So, being able to reduce the mean time to detection, being able to alert exactly when an issue happens, maybe way upstream that you may not have known about, and then telling you exactly where the issue is, where is the actual root cause of the actual issue that took place. That's around improving your mean time to resolution. And then being able to monitor these things at scale is really being able to set you on track to deliver data SLAs and product quality that you're actually building this data for. So again, you have this reactive approach versus proactive approach, or continuous approach, that I always like to talk about and frame that in regard, because if you notice the customers that we had talked about very early on, they kept on saying we can't afford to do X. And really that means is we can't afford to not detect. We can't afford to not have a way to resolve something as fast as we can. We can't afford not to meet our data SLA. So all these kind of things kind of come together when you actually look at a reactive versus continuous approach. And the way our observability kind of solution comes in, and I'm going to go through these slides pretty quickly, and I'm actually going to show you some demos here. Really, you can view it as kind of, and data observability is really around data incident management. You're operationalizing, the alerting that goes on inside of any issues that are detected from process quality to data quality to all the way through lineage. So for example, process quality, this is really around, hey, our pipeline state functioning the way they should? Did it fail? Did it pass? Okay, great. What's the performance of that? Is it up and running? Is it lagging? Is it going too slow? Do we need more resources? Pipeline latency is, did it get there on time? Again, we expected it to complete in an hour and it completed in 5 hours. That's a problem. That's really for data platform and engineering teams. On the analytics and science side, or analytics engineering side, this is really when you're getting into the data quality. You're getting into data structure, data content, data freshness. If you're using something like DBT, you're looking at maybe some of the tests that you're actually performing to make sure those are all good. And then when it comes together to both these teams and how they can take advantage of impact analysis and lineage, this is really trying to figure out, okay, what are relationships between the data and pipelines that are connected to one another, and what are some downstream impacts that could occur? So that's really a big thing that we want to take a look at. And real quick, for the benefits, like what is all this leading to? If you have all these things kind of laid out, if you have the ability to go from process to data quality to lineage, how are these like actually improving things? So we talked about this earlier. It's really around detecting earlier, resolving faster, and then eventually delivering your trusted data. So very simple. When people ask me like, what's the value of using something like Databand or even other data observability tools that are out there? Like what's the value you're getting? It's simple. Detect earlier, resolve faster, deliver trusted data. All these are around speed, cost, and also risk to your business. And being able to tie these things into a modern data stack that includes all these different types of tools is really beneficial for a data team to know that their trusted data is actually being delivered on time without any issues if we didn't detect them. So the demo flow, what I'm going to be going through today is I'm going to be giving some kind of use case examples of, from a data engineering perspective, from maybe an analytics engineering perspective, and then maybe also a data analyst perspective. So from on the Airflow side or all the way to the DBT side, I'm going to be talking kind of in the groups of data engineering, platform engineering, and also analytics engineering. Then when we talk about things going on in Snowflake, maybe looking at some of the tables around that, we're going to be talking about a data analyst side of like what's actually what they actually care about, and how can this all improve them to also detecting issues and resolving them faster. So with that, again, I'm going to do some quick things. I'm going to alert some stuff, observe, analyze, and resolve it in this demo. But before we get to that, what I want to do is, I know we had talked about kind of down below here, the Datacated Takeover. If you put in hashtag Databand, we're going to be giving away some swag. We can mail you some swag. So if you would like to do that, go ahead and do hashtag Databand into the comments right now, because what I'm about to do is I'm going to do this awesome giveaway tool, which is right over here, which allows us to go ahead and pick winners of the swag. So let's see here. We got Carlos doing it, Kate's doing it, Rabbit's doing it, great. John doing it, great. Susan's doing it, awesome. Okay, so I'll give you a couple more minutes, a couple more seconds to add in hashtag Databand, and we will spin the wheel in 10 seconds. But some questions here. Let's see here. Thank you, Kate. Okay, great. Okay, cool. I have some questions here that I can answer, I think, as I do the demo. So this will be good. Okay, let's go ahead and hit the button. Okay. So you have 2 entries. I don't know if that's working. Is that right? That seems weird. Let's draw. Oh, let me go back. Maybe actually, let me exclude winners. Let me do that one. Maybe that'll work. Here. Okay. All right, let me go back here. Maybe we'll try this at the end. For some reason, it's not doing that. R, do a little cache clearing. Okay, so here's what I'm gonna do. I'm gonna come back to this because I don't know what's going on. So I'll come back to this, and I may just pick somebody at random on the comments here. Maybe there's something with live stream. Okay, so I'm gonna go ahead and I'm going to now pivot to be sharing my screen on here. Okay, screen. Here we go. Alrighty, so let's go ahead and do that. Okay, awesome. So everyone should be able to see my screen. I'm going to make myself a little bit smaller here. There we go. Okay, cool. All right, so this is Databand. So if I were to let me do that. That's actually better. Okay, so this is Databand. Inside Databand, you can see we've got a few things down on the left side over here as it relates to kind of consolidating all of your data observability things going on. So dashboard, if you want to see all the things related to different pipelines going on, you can see all the runs, like what are successful, what are running in a dashboard view here. Down below is I've got a few things set up around SLA alerting. So if I have, let's say, a run that should be, executed and completed at a certain time during the day, I can have these SLA analytics that are basically telling me when it deviates from that. So if the average mean time was to get done at 10 a.m., 10:03 a.m., and I set a threshold to be around 10:30, no longer after 10:30, it'll tell me, hey, you had a breach when I actually hit this line here. So this is really good for setting up any type of SLA analytics. Down below, we can also show things like what's going on with your pipelines as it relates to average duration, total run count, errors that could be going on there. All those things that you can see on my screen here. These are all things that help data engineering teams and data platform teams understand what's the success of their pipelines and any errors or failures that could be in troubled pipelines. And they can also have metrics that will also track things like, hey, how has my duration been changing on certain pipelines over time? How many times have they been running? And you can see here, the duration keeps getting longer and longer and longer. So that could be an issue that we want to set up alerts around. And in the pipeline view, what you're seeing here is all of our different pipelines we have set up. So if you have a data stage pipeline, Airflow pipeline, Spark process, a Python job, anything like that, you can set all those things up in here. And you can actually go into each one of these and see all the alerts that are actually set around these different problems. And we're going to get to alerts here in a minute. We're going to kind of hang out there as we go through some of the use cases we talked about. This is just a way to see all the historical records of all the runs that you have. So all your data sets, all your pipelines, they're all in one view. You have the single pane of glass to see all the different things going on across multiple data teams. So for example, this one here, this is service 301 close request. That's our name of our pipeline. It's very troubled. We got a lot of issues here. So then this is actually the demo environment I'll be talking about today as we walk through. Okay, runs are the same thing. So if you want to look at all the individual runs related to those pipelines, you can also see that, do any filtering you want at the top here. And what we're going to do now is kind of camp out under this alert section. So the key thing around Databand and a lot of observability tools that are out there today is that it's really, the power really comes in the alerts you can set up around that metadata that you have. So if I had, a bunch of different pipelines or tables in certain warehouses, I can go in here and add different alerts. So things like pipeline state. This is what we talked about on those three buckets we set around process quality, data quality, and also lineage. So if you want to know if your pipelines failed or succeed, you can add one of those. Pipeline duration, is it in the outside or defined limits that you've already set? And you can set up anomaly detection around that. Data quality within pipelines, checking data sets logged within your pipelines, and also checking tables and data warehouses that are monitored in your database. So I'm not going to go through all of these, but this is just an example of how you can set up different alerts with different teams, different pipelines, different tables, and different projects inside Databand. So it's all clean in regards to the alerts that you're actually getting. And all those alerts can be different severities and different priorities whenever things are alerted to your team. So let's go ahead and talk about an example of a data engineering team. So if I'm a data engineering team and I'm monitoring a particular pipeline that I want to make sure is always kind of running within a particular duration, I want to make sure that it's always going to be complete in a certain time. So for example, over here, I've got this run set up on a duration that around the type of how long it actually took to complete. So if I click on this alert here, is the high duration alert. There's an error here. You can see that I had set this alert to trigger whenever it goes above a certain value. So if I had 150 seconds as like the trigger value, which is around 2 minutes or whatever, I can set an alert to say, hey, when you breach that, it's going to at 186, it's going to tell me right away that there's an actual issue here. So this is really a pipeline duration alert. The pipeline actually ran totally fine. So if I go to the actual pipeline inside Databand, you can click that and go right to it. You can see that, the pipeline ran fine. There was no issues with that particular pipeline. Even if I go to the run details screen, you'll see that in the particular DAG view, everything looks green, right? No, there's no problems here with this particular pipeline. But if I had a downstream consumer that was consuming the data from this pipeline, they want to make sure that it's actually there every single time at within a certain threshold of time to have this pipeline execute, so that they can actually consume that data. And I can go back and kind of look at, how this pipeline's kind of been performing over time, different runs that it has here. So sometimes it runs at has certain records that are written that may indicate that the more records they're wrote into the system, the longer the duration is. That could tell us that maybe we need to update our resources as part of this pipeline so we don't run into this issue. And also, if you look down here, you can see things like, hey, this is where it actually ran, was running on time, but the amount of read and write records that we actually sent were a lot lower. So again, it could be indicating the reason why this is performing late, or there's a latency in the particular pipeline, could be a resource issue. And so this is an indicator to the data engineering team that, hey, we got to bump up our resources or look about how much data we're actually ingesting. Kate said there are a lot of alerts on there. Is that a good thing? Since this is a demo environment, we have a lot of alerts in there. You can resolve a lot of the alerts that are there. So I just don't resolve a lot of these alerts, because when I'm doing the demo, I want to show people kind of all the different types and flavors of alerts that are there. But no, you can actually resolve the alerts, and alert's going to go down. But we also keep the historical record of all those alerts as well, so you can go back and look and see, how many times we raised an alert on this particular issue. So that's an example of a data engineering person that is actually going through, and they are looking at their pipeline. It ran fine, but they may need to bump up the resources they're a part of that. If I go back to the alert screen, I'm going to look at a few other things here. So if I scroll down here, you can see that we've got a alert. I'm going to look for a critical alert rather, that we're having a failure. So I'll go back to that one in a minute, but let me actually show you an example of if I'm an analytics engineer, and let's say I'm using something with DBT. So analytics engineering, obviously it can cover a lot of different things. Like a lot of times they go soup to nuts, from doing the orchestration to interacting with DBT to all the way to a Snowflake warehouse. But a lot of times they kind of hang out in this DBT world. So if you had, let's say, an Airflow job connecting to a DBT process, connecting to a Snowflake process, a lot of these things that are actually generated are around the analytics engineering domain. So in this one right here, you can see that I had a DBT test failure with service 301 get request. So if I click into this, you'll see that basically I had a alert triggered around any test that's a part of my DBT process that particularly failed. So in this example, we're checking to make sure there wasn't not any null records that were in a certain column. We found that there actually was some nulls in that particular column. And this gives you all the information of your DBT process, all the way to kind of what failed around this particular issue, which is this close request issue right there. Very much similar to the way you would see it inside DBT. So this works with DBT Cloud and also DBT Core. But if you see all the data in one place, you don't have to hop back and forth between, hey, I just found that there is an error in DBT Cloud or DBT Core. I want to have all this in one place so I can analyze it and understand kind of what's going on. We also give you all of the error messages that occurred. So this is the same thing we just kind of showed you here, the DBT test query that's a part of that. And then also you can see the query underneath this. So this is all the DBT model query that's here. Again, same thing you would see inside DBT. Now we're pulling that in for one single view to actually analyze it. So that's great. If I can see, hey, we had a test failed inside DBT. If I'm an analytics engineer, this is great. So I can see exactly kind of what happened. And then what I can also do is I can look at the particular run that this came from. So inside Databand, what we try to do is give you all the information so that you can make the best analysis of where to go fix something, or what's the context of why this thing actually failed. So inside here, I just clicked on the run that's a part of this pipeline. And if I go to, actually, let me go to this guy here. Sorry. There we go. There it is. So inside here, so this is the run. This is the overall run of the DBT job that we just showed. And if you go over here, this is the DAG view that connects everything. So you see that we had an Airflow process connected into a DBT load sensor over here. And then down below, as you see all the different errors that are associated with that particular DBT process. So if I'm a analytics engineer and I want to understand the entire flow from a ingestion process from Airflow to DBT that then is going to also push into a Snowflake table or do some transformations that are in a Snowflake table, that's where I can see all this information right here. And if I click on any of these models here, I'll go ahead and open up this guy. We have a load issue. Hold on 1 second. Testing this before. It seems like there's a little bit of a lag between. There it goes. Okay, there we go. So it's back. Okay, so there's some issues with live stream right now. Okay, so over here, what you can see is if I click on any of these different components inside the DBT job, what you can go is you can go to the actual run information or code rather, and you can see the exact information that we just talked about. So here's where things failed. Here's where things, some of the tests that actually didn't work. And if I go into the actual run here, I can also see more information around this. So all the data interactions that are a part of your DBT job, those are all here for you to see. We want to make sure that it's very much clear for everyone to diagnose any issues, a part of like kind of what's going on here. Let me go to the detail screen. There we go. So there's the run, there's the test, the parameters are here, here's where it failed, and so on. So you can see all those kind of all in one place. And if I click on any of these individual items over here, I'll get more information to take a look at. You can also see the different runs periods in this DBT job. So if anything happened in the past where I can go back and look at those historical records, I can see all that information there as well. So as a quick view, what I've shown is, I've showed a data engineering workflow. I've showed kind of an analytics engineering workflow. And again, I'm trying not to make this in a pure isolation standpoint, but I can see exactly, things that engineers care about, maybe some things that DBT user would care about. The next one is if you had something that was totally disconnected from this, and this is really, if you're only wanting to look at a process that is inside maybe a Snowflake table. So what I'm gonna do now is kind of show you if I'm just a data analyst and I want to be alerted on anything going on with data freshness or null records or issues within maybe a Snowflake table, we can also observe those tables and see what the issues are there. So I'm gonna go ahead and go to a new section here. Give me 1 second. Okay, so inside here, what we're going to do now is, from a data analyst perspective, what I'm going to do now is actually how we do our Snowflake integration. So inside of Snowflake, you have the ability to basically integrate to whatever tables and columns that you care about. So whether you're going to use traditional integration details or like an authentication means, you can do that. But what I want to do now is kind of show up how I've actually set up these particular tables. So inside of here, these are all the data sets that are a part of either Snowflake or Redshift or any other warehouse I'm connected into. This particular one here, if I click into it, you'll be able to see that these are all the records that I'm pulling in from a particular table. Here's the path to my Snowflake environment as well. And then also kind of what was the last operations that occurred. So I can see all the number of daily rows that are written in red, daily operations that occur on this particular table. And then also anything from a write and read perspective as well, and kind of the individual components. So I can see that there as well. This Snowflake integration is really powerful for customers that are kind of either migrating to Snowflake or they're kind of on a journey to Snowflake. This is a great way to kind of house everything in one place. The next step here is if I go. I apologize. I'm like a little bit laggy for some reason. Could be the storms in Atlanta. Okay, here we go. So now what I'm showing is, oh, looks like StreamYard is possibly. Okay, so I think I was on mute there. So sorry about that. So what I'm doing here is I'm just setting up a connection to my Snowflake table, and what I'm also doing is I'm setting up um, the different columns that I want to connect into. So if I want to go ahead and select from this column and I want to do a metric run not null or unique, I will do that. And this is allowing me just to set up the different alerts that I want inside of Snowflake. So in this column here, I'm maybe doing some other metrics as well. So basically, I'm checking for nulls that I don't want, or I'm checking for any uniqueness or duplicates that go on there. So once I do that, that's all set up. And now I've got an alert that I'm going to take a look at that was based off of that particular alert that was created. So for here, there's 562 values of not vote values in a particular column. And I can click in here to see kind of why that alert was set up. So now that I kind of have these alerts set up on these particular tables, anytime that I find more records that are around there, I can just kind of hop in and get into it, right? This is a great way if you don't have, let's say, a full if you really don't want to look at a full end-to-end flow between airflow to dbt to Snowflake, and you just want to look at, hey, check some certain tables on my Snowflake environment for issues around it to data freshness or data accuracy, we can do that just by looking directly at the tables as I set up that configuration. And I apologize, I was talking on mute, so that was a problem in the past. Okay, so this is an example, again, looking at all the different runs that are part of, let's say, a DBT process. Now it's connected into a Snowflake table. So again, that same issue that we got alerted on that may be connected into a Snowflake or Snowflake table is also now part of our DBT run that we had. So this is kind of showing a different view of how I set that up, either from an Airflow environment to a DBT environment all the way to a Snowflake environment. So all right, I'm going to go ahead and pause here. Go ahead, stop that. Okay, so getting back to our environment. So I'm back over here now. You guys can see me. Hopefully I'm not muted again. But that was just a quick example of just kind of how all this kind of comes together. And if you want a demo of Databand, or if you want to, if I can walk you through kind of more use cases, if you're using things like Spark or using things like BigQuery, we have all that kind of set up in different demo environments so we can walk you through. But hopefully you got a clean idea of how to, if you have problems with data reliability, whether it's from process quality, data quality, or even lineage, we can show all that kind of in one place connected together. So I'll pause here, and I think we're back to doing a few questions. And let me go back to over here. Let me go ask some questions here. Okay, so comments. Let's see here. Okay. Go back to our alerts are, so George asks, are the alerts set per hour or configurable? So what we do is, depending on which alert it is, it can be real time. So it's like when something actually occurs. So if you had a run that is actually running and it gets to a certain threshold where you say, hey, we set to alert us that we don't have a pipeline latency over 1 hour. When it hits 101 and it keeps going, it'll alert you based off of that. For Snowflake, you can, for different table queries, you can set different hourly increments to query the Snowflake table, so you're not constantly querying the table all the time. Hopefully that answered your question there. Let's see here. question. Ideally, this should be made business as well as tech friendly. Yeah. So, question was asking about kind of how things are displayed. So, I would say most of the time, most of our engineering teams, the way that the people we talk to, mostly are data engineering, data platform, analytics engineering teams, right? If you're looking for like a pure and they're used to using tools that are very much in the observability angle as a tool like, let's say, Instana or New Relic or Datadog, you'll notice a lot of our debugging and root cause analysis capabilities are very similar to those types of observability solutions. Now, if you have, what I didn't really go into is a lot of the dashboard functionality that you can have kind of rolled up in a view. There'll be more for an executive standpoint. That's something else that we provide as well. Just didn't really get into that as well. Kate asks, who would use Databand more, analytics engineers, data engineers? Mainly data engineering teams, but also now data analytics engineering when we get into using things like DBT and Snowflake and things like that. So we've traditionally kind of catered to the data platform and data engineering side, and now we're factoring more into the analytics engineering side and data analyst side. Let's see here. Demo went faster than making coffee. Yes, it did. So what's cool is that you can see all of our videos, all the things I just talked about. You can see all those videos online, ungated at databand.ai. So if you ever want to go and just like listen to any of me talk more and more, I'm happy if you just want to go there and take a look at the videos we have. Also, if you want a demo, we can actually give you a demo as well. Question from Angel: how does data observability relate to data ops? So the way this relates to data ops is, when you think about data ops and how that actually functions, a lot of the things that go on in data ops is the moving of, hey, orchestrating the data to developing, to testing it, to then getting it out into production, right? The way observability plays into that is that it's basically a monitoring layer over all of those processes. So ingestion to transformation to consumption. That's where we're helping out this data ops environment. Very much so like DevOps. Like DevOps, like what you're doing in DevOps, you're at the very end of your cycle or in production. What are you doing? You're inserting a shift right model for observing things as they're happening in production. Because you want to make sure you catch things that may have leaked out into production. Very similar to what Databand's used for. Databand can be used in staging environments. It can be used in internal environments, or most of the time our customers leverage in production environments where they're actually monitoring their workloads in production. Let's see if there's any more questions here. A lot of like comments of people just talking about colors and things in here. So it's kind of funny. Oh man. Okay. Let's see here. Question about like, hey, how is Databand deployed? So it's deployed in SaaS or on premise. So depending on where you want to, use this as a service, or if you want to deploy it on premise, we have both options for that. What's interesting is a lot of data observability solutions out there are either or, and they're not both and. What's great about us is we're both and, so that we can actually have for enterprise more use cases are more kind of locked down. For example, a lot of our customers are bigger banks. Some of them are, and some of them are smaller, medium-sized businesses or do everything in the cloud. So it really depends on kind of what your environment is for the setup. Okay, let's see here. Okay, cool. I'm going to try. Oh, here we go. I'm going to try to do this one last time, and then we will head out for the day. Okay, so let's go ahead and do the drawing. Go ahead and share my screen here. Let's go to share screen. All right, so we got 11 entries now. Let's draw them. Let's see who won. Let's see who. Winner, Andrew Green. All right, Andrew, I will look to send you some stuff. Let's if you did win, or Andrew, if you have that there, let's go ahead and I guess you get your contact information. I'll get your email information from Kate as well, as we kind of round out here. Last question. Thanks, DevOps process should cater for picking up anomalies. Yeah, so we do pick up anomalies. That's a big thing that we do. I mean, all of the kind of things that you saw there was around detecting data anomalies, schema changes, pipeline latency, pipeline statuses, things like that all those things, whether it's pipeline monitoring or data quality monitoring, a lot of those things are actually powered by our ML anomaly detection. So definitely is something that we have inside of our wheelhouse. All right. So with that, I'm probably gonna sign off here. Thanks for everyone to join the DATAcated Live event. Again, if you have any more information, go to databand.ai, and happy to talk more about it on LinkedIn or anywhere else. So thank you so much, and congratulations to Andrew for the winner. And I'll look to get you some swag in the next week or so. All right, everyone, take care.